Hello and welcome to Motorboats Monthly's practical section, brought to you by Garmin. Today we're going to be looking at carrying out a secondary port calculation. Now the almanac is full of tide tables, and these are mainly standard ports. Standard ports are often quite far apart on the coast, and there's lots of ports in between the standard ports, and those ports are known as secondary ports. By doing a secondary port calculation, what you're able to calculate is the time and the height of high water at those secondary ports. So the secondary port we're going to look at today is the port of Rochford at the head of the River Roch. The first thing we notice about this from looking at the chart is that the moorings there dry to 1.5 metres. So obviously we can't get in at low water, so working out the time of high water is very important. It's equally important to work out the height of tide for this port, because with a drying height of 1.5 metres, our window to get in is going to be quite small, possibly even not at all on small tide. So we're going to work out the height and the time for a visit to Rochford on the 17th of March this year. Right, so the first thing we need to do is to find Rochford, the River Roch, in the almanac. We've got it here, and what we can see from this is it tells us that the standard port for the River Roch and for Rochford is Walton-on-the-Naze. It also gives us a nice handy arrow that tells us which direction in the almanac we can find the Walton-on-the-Naze tide tables. So we're going to turn to that. There we go, Walton-on-the-Naze, and we're going to find the height and the time of high water at Walton-on-the-Naze for our chosen date, which is the 17th of March. So we can see from there that the high water is at 1503 and the height is 3.8 metres. So we're going to make a note of that. Now we need to turn back to the page with Rochford on and start looking at the differences. Now what we can see here is it gives us differences for Rochford, and it tells us that high water will be between 50 minutes later, plus 50, and 40 minutes later. So the differences between the high water at Walton-on-the-Naze and the high water at Rochford will be between 40 and 50 minutes later at Rochford. Now the reason you've got two times here is it depends when high water falls. If high water falls at midnight or midday, the differences for Rochford is plus 50 minutes, and if high water falls at 0600 in the morning or 1800 in the afternoon, the differences are 40 minutes on the Walton time. If high water falls anywhere between these, then you need to do a calculation, you need to interpolate between the two differences. So if it was at 3 o'clock in the morning, which is exactly in the middle, it would be 45 minutes later, and so on. Now obviously there's only 10 minutes difference here. On some ports there is a much bigger difference, and the interpolation is a little bit more important. So for this example, we've got high water at 3 o'clock in the afternoon, which is exactly between 12 o'clock midday and 1800. So we know that the difference for the high water at Rochford is plus 45 minutes. So we're going to make a note of that. And now we can start looking at the height of tide. Now the heights work in a very similar way. You've got a mean high water spring level of 4.2 here, and a mean high water neap level of 3.4 metres here. And the differences for Rochford is between minus 0.8 and minus 1.1, so the tides are going to be that much less at Rochford. And again we can interpolate the difference. Our high water is at 3.8, which again conveniently is slap bang in the middle there, which means that the height difference will be slap bang in the middle between 0.8 and 1.1, which works out, if you want to be precise, at 0.95 of a metre less tide at Rochford than we have on Walton-on-the-Naze. So we can add that to our notes now. So now that we have those calculations, we can work out the exact time and height of high water at Rochford by doing a little bit of simple mental arithmetic. So we know that high water is going to be 1503 plus 45 minutes, so it'll be 1548. And we know that the height will be 3.8 metres less 0.95 metres, so we'll have a height of 2.85 metres. Now we know that the moorings there dry to 1.5 metres, so we could take that off if we wanted to. Minus 1.5 leaves us with an actual water depth on the moorings of 1.35 metres at high water. Now we need a metre to float, and we now know that we've got 1.35 metres of water at high water on the moorings. So that means that the timing is very critical. We've only got 1/3 of a metre spare. We really need to arrive bang on high water. So it's a great example here of why working out these secondary ports is important. because potentially if we were to arrive only half an hour after high water, we could be stuck on the mud for maybe up to 11 hours. So that's secondary port calculations. They're really not that difficult, and they can open up a whole new cruising area for you. All of those drying ports and harbours in your area you can now visit after doing a simple calculation like we've just done there. There is just one last consideration, and that's barometric pressure. The pressure on the day can increase or decrease the tide by a considerable amount. To find out more about how barometric pressure can affect the tides, read this month's magazine. Well, I hope you found that useful. Thanks for watching.